Okay, I repeat again, yeah. A stationary body is acted upon by a number of force. Yeah. State the two conditions which must apply for the body to remain at rest. Yeah. At rest is something they don't have any acceleration. Yeah. They don't have any acceleration or they don't have velocity. Uh, this is in equilibrium. Yeah. So in the equilibrium, the total force, yeah, acting on this object seem equals to zero. Yeah. And the second one is total moment of force, yeah, equals to zero too. Yeah. Ya, kalau if I draw it, ya, ya, last uh, meeting, equilibrium is when two condition, that total force equals to zero and total moment of force equals to zero. Yeah. This is between in x or in y. Total force in x equals to zero, so total F in y equals to zero too. Yeah, that's it. This we call it as a in equilibrium. Okay, question A. Then question B. Figure 3.1 shows a device used compressing crushed material. Yeah, this is lever arm. Yeah, the length lever arm is 380 millimeter plus 120 equals to 500 millimeter. Yeah, 500 millimeter. And they have force 20 newton on the left side, and they have force also here. Yeah, this is plunger cylinder cross material section. Okay, the lever arm rotates about the hinge edge. This one, yeah. I think this is about pivot, yeah. Hinge edge. At the right hand end, yeah, force 20 newton acting downward, yeah, this one, of the left hand and the lever arms, yeah. The force F of the crush material on the planar act upward, yeah. Ignore the weight of lever arm. Okay, ignore the weight lever arm. So they don't have any weight, yeah. Question I. Use the clockwise and anti-clockwise moments about each to calculate the upward force F, yeah, which the crush material exerts on the plank. The distance are shown in the figure 3.1. Okay, they need about how much force is here. Yeah, by using clockwise and anti-clockwise moments. Yeah, so uh, this, yeah, on the anti-clockwise 20 Newton, yeah, times distance. Yeah, distance is from 20 Newton into height, yeah, into h. Yeah, this is 500 millimeter, yeah, from 380 plus 120, yeah, and this is equals to force, yeah, and distance force to hang is 120, 120. So force equals to, this is 10, yeah, 10,000 divided 120. How much is it? 10,000 divided, this is about 83, yeah, 83, 83 Newton. Yeah. Yeah. Okay, that's it. Yeah. The next question. Okay, the cross-sectional area A of the plunger is inconstant with crush material is 0.0036 meter persegi. Calculate the pressure exerted across material by plunger. Oh, this one, pressure. Yeah, pressure is, force times A. Yeah, sorry. Pressure is force over A. Yeah. Uh, Force is, we have force equals to 83 Newton divided A is 0.0036 ya. So coba kita hitung divided 0.0036. Oh, so big ya. 23,000. Oh, 23,000 148.15, yeah, in Pascal. Or maybe if we simplify this, yeah, 1, 2, 3, 4, 5, about 2.3 times 10 to the power 5 Pascal. That's it. Ya, kita cek aja. Number 3, figure 2.1 is head-on view of an airliner flying at a constant speed in the circular horizon path. The center of the circle is to the left of the diagram. Okay. Draw the resultant force acting on the airliner. Yeah. Explain your answer. Draw the wait. The center circle is to the left of the diagram. Iya sih mungkin di sini. Okay. Draw the resultant force acting on the airliner. Explain your answer. Oh yeah, we have weight. Yeah, only weight. Yeah, because we see in front. Yeah, only weight. Yeah. But if we see in the B side, maybe we have some force. Yeah. This is like driving force. Yeah. And we have weight. Yeah. And we have resisting force. Yeah. And we have like buoyancy force. Yeah. This is weight, and this is like for Archimedes. Yeah. So if like this is only one, maybe only weight. Yeah, because we see in the front of. Yeah. So draw the result from expand your answer. Yeah. We see only weight. Yeah. Yeah. Because from from front, ya, kita ngelihatnya dari depan, ya. Gitu. Okay, let's check B. The weight of airline is 1.20 10 to the power 6 Newton, and there is an aerodynamic lift force 1.39 times 10 to the power 6 Newton acting at 30 to the left of the vertical. By drawing a scale diagram in or other ways, so that the resultant of two vector forces the same direction. as the resultant force you throw. Okay, this I don't. The weight on the oh yeah, this is actually like uh, force uh, with cos 30 equals to 1.39 times 10 to the power 6. Yeah, cos 30 is maybe 1.2. Let me check here. 1,39 cos 30. 1,20, yes, correct. This is about 1.2 times 10 to the power 6. Yeah, Newton. So same thing with this one, yeah. Same thing with this one, yeah. Between this cos 30, yeah, equals to 1.2 times 10 to the power 6. So we can decide about why like this one, yeah. This is oh, when we have force. Oh, kok merah. Oh, this is weak. So this is 30. So this is F cos 30. Yeah. This is F. Yeah. Actually, F cos 30 is same thing with weight. Yeah. Yeah, that's it. Okay, I think enough. 5 minutes. Yeah. We see other question. See question. The speed is constant as the airline flies in the circular path. State and explain what happening to the velocity. State and explain what happened. The speed is constant. Oh, velocity is change direction. Yeah. Uh, we draw it. Yeah. If this is a trace of the aeroplane. Yeah. So speed constant. Yeah. Speed constant. Yeah. But velocity is change in the direction. Yeah. Uh, this is speed constant. Speed is constant. Yeah. Speed is uh, scalar quantity. Yeah. Scalar quantity. Yeah. But velocity is change. Velocity change. Yeah. Yeah. You see this when the position is here, the direction velocity is, yeah. This is v. Yeah. V velocity change the direction. This is also change. Yeah. This is change. Yeah. This is change. Yeah. Yeah. The direction of velocity, yeah, is change. Yeah. So velocity, yeah, as a vector quantity, yeah, as a vector quantity is, oh, change. Yeah. Change in direction. Yeah. In direction. That's it. Ini change berubah, setiap posisi selalu berubah ya. Dan biasanya dia adalah right angle with the center of this path ya. Nah, ini question 4. Figure 3.1 shows an airplane mass 3.4 times 10 to the power 5 kilogram accelerating uniform from rest along a runway. Okay, after 26 seconds, it reached speed of 65 meters per second. Yeah. Calculate. They have several questions here. For A, calculate the acceleration of aeroplane. Oh, question I. Acceleration is change in velocity, yeah, divided time. Yeah. They have changed in after reach 65 from 0 in time 26. Yeah. So they have acceleration about 65 divided the 6, 2.5. Yeah. Okay. This is about 2.5 meter per second square. Okay, this is about the acceleration. Yeah, 2.5 meter second minus 2. Yeah, for the question I. Still A question. Yeah, and then question I. Yeah, the resultant force on the airplane. Resultant force equals to ma. Yeah, mass, they have mass 3.4 times 10 to the power 6. Yeah, 5 kilogram, and then times velocity is acceleration is 2.5. Yeah. If we calculate this number, yeah, yeah, 8.5. This about 8.5 times 10 to the power 5 Newton. Yeah. Okay. Yeah. Question I. We use the formula F equals to ma. This is also A equals to delta V over delta T. Then, what about B question? Just after taking off, the urban continue accelerated gains hike. Yeah. State to form energy. Yeah. That increased during this time. Yeah, energy. What energy? Kinetic energy. Yeah. Kinetic energy and what else? To form energy increasing. Potential energy. Why potential energy? Because they have high. Yeah. Okay.